Hi everybody, so let us take this question. This question was asked in GATE 2017 in electronics paper, right? In set 2, you can say for 2 marks. So let us solve this question. This question is from delay in combinational circuits from digital circuits, okay? So let us solve this question. This question is of two-step process, okay? If you carefully look at this question, right? So figure 1 shows a 4-bit ripple carry adder realized using full adders, and figure 2 shows the circuit of the full adder. So here the circuit of the full adder is consisting of, you can say, XOR gate, AND gate, XOR gates, okay? So this is first XOR gate, second XOR gate, okay? This is first AND gate, second AND gate, and this is the only one OR gate, right? Okay. The corresponding propagation delays are also given. The propagation delay of the XOR and an OR gates given 20 nanosecond, 15 nanosecond, 10 nanosecond. Assume all the inputs to the 4-bit adder are initially reset to 0. Okay, so this is, you can say, 15 second you can spend on reading and understanding the question. At t equal to 0, the input to the 4-bit adders are changed to. Now they have given some specific input, so your problem becomes very simple, right? The moment they have given some specified input, so the problem becomes very simple. Okay, so you see here, the output of ripple carry adder will be stable at. So you have to find the maximum propagation delay at which the output of the ripple carry adder is going to be stable. Okay, it can be the sum or it can be the carry also. So the maximum of the overall, suppose we get sum at certain nanosecond and the carry at certain nanosecond, the maximum is going to be the answer. So let us solve the question. So forget about all the delays at this moment and try to add. Okay, start adding the inputs, right? So we have been given input here. You can say x3, x2, x1. So you can say this is the input 1 1 0 0, and the second input is given as 1 0 0, right? So you know that this is nothing but a ripple carry adder. So these carries are going to be propagated, like starting from Z0, Z1, Z2, Z3, and Z4, right? So we have to see now. Let us add this these two inputs. Okay, you can say we are adding, this is X0 and Y0. You can say X0 and Y0, and this is 1, right? Okay, so whether you just simply forget about this Z0 and all, right? Just simply add this. Okay, so 0 0 means you can say this is going to be 0, and this is 0 0 means this is going to be 0, right? So if you take 1 as well, there no carry will be generated. Okay, so this Z1 is gonna be 0 only, so you can consider 1 as well, okay, if you want, right? But the carry, it is not going to generate. You can see here, if you take 1 here, right? So you can say 0 0 plus 1. Okay, so it will be giving you 1, but no carry will be generated. So forget about this, you can say this initial carry that is given. So 0 0, this is 0. Now you will start getting carry from here onwards. You can say 1 1, this is going to be 0. So I have added 0 0 here. Okay, so if you take, this is 1, so it is going to be 0 only, right? Okay, S0 is going to be, you can say 0 0 means 0. Okay, you consider this is okay, and now it will be 0, right? Your carry is going to be 0, your sum is also 0 here. Now 0 0 means it is 0 and the carry is going to be 0, right? Now if you add 1 1, this is nothing but x2 and by 2, right? X2 by 2, you can say 1 1, right? So 1 1, and here it is going to be 0. Your, okay, this is going to be 0, but your carry is going to be 1. But we have to see after what nanosecond this carry is going to become 1, right? That is very important. Okay, because all the gates are associated with some certain propagation delay, right? So since the carry is going to be generated after adding, you can say by 2 and x2, so we have to apply these inputs. Okay, we don't have to check for 0 0 and 0 0. You can say we don't have to check for y0 and x0. We don't have to check for y1 and x1, right? We have to start checking. We have to apply inputs in the given socket of the full adder, right? So you just apply here. So you can say this is going to be x2 and this is y2, and this is nothing but Z2. So you can say this is nothing but 1 1, and this is nothing but what, 0. Your Z2 is 0, right? So you see here, if you take a look at first XOR gate has got 20 nanosecond delay, right? So it is going to respond after 20 nanoseconds. So since we know the property of XOR gate basically exclude the status being same, right? So if the input is same, output is always going to be 0, right? irrespective of whether it is 1 1 or 0 0. But when you will get this 0 here, so this 0 will be available after 20 nanosecond, right? So I'm just going to mention here the 20. I'm not going to mention the unit. You have to consider it. Now let us focus at the output of first AND gate. So it, both the inputs are 1 tied to 1, right? You can say the output is going to be 1 only, but after what nanosecond? You have to say that it will be nothing but 15 nanosecond. Why? Because they have mentioned here the corresponding delays. One is 20, one is 15, one is 10, right? So these has to be concentrated, okay, while getting the output of each gates. Now you see this one is available here at, you can say, 15 nanosecond. But now you see this is 0, so you can say this is 0, right? Okay, this is 0, this is 0. Okay, now your sum is going to be 0 only, but after what nanoseconds? You can say this is directly available at this second or XOR gate, but this is coming after 20 nanoseconds. So you have to wait for 20 nanoseconds, and when your XOR 2 is going to respond after 20 nanoseconds, so it becomes 40, right? So your output is going to be stable, right? You can say sum is going to be stable. After adding, you can say by 2 and x2, it takes 40 nanoseconds to be stable. Now let us talk about carry. This carry is going to be Z3, you can say. You see, once you add x2 and by 2, so you're going to get Z3 as 1. But after what nanosecond, that we have to check, right? So since either of the input is 1 of, if I'm going to focus at OR gate, okay, so OR gate property is what? If any one of the input is 1, output is going to be always high. But after what nanosecond it is going to be high, that is very important. So as long as whether it is 1 or 0, we don't care about. So this AND gate is not going to play any role to decide what the carry Z3, you can say. So this Z3 is going to be 1. Okay, you can say this is nothing but Z3, right? After considering the you can say it will be available at 15 nanosecond, this one, and this is going to respond after 10 nanoseconds. So your Z3 will be available at 25 nanosecond, right? You can say that this Z3 will be available at 25 nanosecond. Okay, this AND gate is not going to do anything here. No wonders here. You can forget about this AND gate. Okay, fine. Because you can also see here this is 0 here and this is 0. It is coming after 20 nanosecond, right? But as we know that any one of the input is 1, XOR gate is going to respond. It is not going to wait for the output of, you can say, any second input of the OR gate, right? I believe this is fine. Yeah. So this is the property of OR gate that you have to remember. Now let us see once we add this. Now Z3 is available after 25 nanoseconds. So let us apply here the input. You can say 1 and you can say this is nothing but 0. This is nothing but 1. Now this S3 is, you can say, what will be S3? S3 will be 0 only. You can say 1 0 means 0. Now Z4 will be available at what nanosecond, right? And when we are going to get this 0, that is also very important. So let us apply here the input in this. So you can say this is X3 by 3 and this is Z3. So Z3 is 1 after 25 nanosecond. Please remember this, okay? I'm talking about last full adder. So this is nothing but 1, this is 0. Okay, now 1 0, the output is going to be 1 after 20 nanosecond. You know, the XOR gate, both inputs are different. The XOR gate is going to respond as 1. XOR gate is going to be high. Output of XOR gate is going to be high after 20 nanosecond. Now you see here this is 1 and 0, so certainly it is going to be 0, but after what nanoseconds? You can say 15 nanosecond, because you know that 20, 15 and 10, these are the corresponding delays associated with these gates, right? So this is first, second, and this is first only, right? Yeah, fine. Now let us see why this is responding at 20 nanosecond, because you know that this Z3 is not going to affect this XOR, okay, first XOR. Now but Z3 is going to affect the second XOR. You can say this one will be available at 25 nanosecond, okay, but this one is available at 20 nanosecond. So this XOR gate has to wait till 25 nanosecond, then it will respond after 20 more seconds, 20 more nanosecond. You can say this is going to be, it is S3. S3 is going to be 0 or stable after, you can say, 45 nanoseconds, right? So we always consider the maximum delay till up to that we have to wait, the gate has to wait, okay, to respond. Now this is 1, okay, this 1, and this is nothing but 1 only, right? So this you can say this is 0, right? Now this AND gate is going to respond. As we know that as long as the either of the input is 1 of OR gate, okay, it is going to be 1 only, right? It is going to be stable, but after what nanosecond, right? That is very important. So this one is available at 20 nanosecond, but this one is available at 25 nanosecond. So 25 nanosecond plus the gate plus the propagation delay introduced by this second AND gate, this one will be available at 40 nanosecond. You can see, right? 25 plus 15. Now this input is 1, output is going to be stable only after what nanosecond. So 40 plus this propagation delay, that is 10. So 40 plus 10, this is going to be 50. Okay, so you can see here the sum is going to be stable at 45 nanosecond and the carry is going to be stable at 15 nanosecond. What is the maximum propagation delay at which? Okay, that is the answer. Okay, that is what we have to find. So the output of ripple carrier will be stable at 50 nanosecond. Answer will not be 45, it will be 50. So I hope this solution is clear. This question is very simple question, provided you should know how to analyze the circuit, okay, and the basic concept is clear, and whatever theory you have learned, always try to match with the question, then only you will be able to solve this kind of question. Thank you so much. We'll meet in the next session. Yeah.